Okay, so in this lesson we're going to be differentiating polynomials that have negative indices, and we'll begin with single terms, with monomials first. And it turns out that the rule doesn't change. So if we were going to differentiate x to the minus 3, the minus 3 comes down and you minus 1 of the power, which is a minus 4, and this is the only thing that can be a bit tricky. It's not minus 2, that's adding a power. We want to minus a power, so it becomes minus 4. If we want to differentiate minus x to the minus 8, the minus 8 comes down, multiplies that minus to give you positive 8, and then you subtract 1 of the power, becomes a minus 9. In this example, 2x to the minus 9, the minus 9 comes down, multiplies to 2 to give you minus 18x, and you subtract 1 from the power. And here the minus 2 comes down, multiplies to minus 3 to give you positive 6x to the minus 3. Okay, so next we're going to differentiate reciprocal terms. And here's a reciprocal term. A reciprocal term is when the x is in the denominator of a fraction. And as it is, we can't differentiate it straight away. So you can't differentiate it term by term, it won't work. You're meant to first convert it into a negative indice, so we do that. So that's d dx, so 1 over x to the 4, that's x to the minus 4. And only when it's in this form we can now differentiate it, so the minus 4 comes down, and then you minus 1 of the power is minus 5. And that's the answer, and that's finished. But we can put it back in as a fraction if we want, and I'll just do that. And these are both the answers, so either one should be fine. And I'll just illustrate why we have to do this. Let's suppose we decided not to do that. We thought we can just differentiate it straight away. You might think maybe that becomes 1 over, and if you differentiate it, it becomes 4x cubed. But you can see they're different. So we don't differentiate it. Also, when you differentiate 1, you get a 0 anyway, but some people make this mistake, so don't do that. Do this. Okay, next example, we want to differentiate 8 over x. So we first convert it to a negative indice. That's 8x to the minus 1. So the x comes up as a x to the minus 1. And now we can differentiate this normally. And that's finished, but I'm also going to just convert it into a fraction again. There. So sometimes you can leave it like that. If you're given it as a fraction, I like to give it back as a fraction. But if you're given it the question as a negative indice, you can leave it as a negative indice. Okay, the next example, we have to be a little bit careful here. There's a common mistake, so we want to bring this x cubed up, but the mistake is as follows. Sometimes people bring the 5 up as well, so we might think that's it, the 5 has gone up with the x, but that's going to give us the wrong answer. That's not what we do, because the cube is only acting on the x and not the 5. So the 5 stays as a 1/5, it stays in the denominator. So the correct method is that this becomes 1/5 x to the minus 3. Only the x cubed goes up and the 5 stays where it is. And now we can differentiate this normally. The minus 3 comes down, minus 3/5 x to the minus 4. Okay, the next example, we're going to differentiate 4 over 5x to the 6, and again the 5 doesn't come up with that, only the x to the 6 will come up. So this is a fraction 4/5 x to the minus 6, and now we can differentiate. The minus 6 comes down, gives us minus 24 over 5 x to the minus 7. The next example, we're going to differentiate negative pi root 2 over 7x squared. So again, these are just numbers, they stay exactly where they are as a fraction, and the x squared will come up. So the fraction part is minus pi root 2 over 7, and then we have x to the minus 2. And now we can differentiate it. The minus 2 will come down and multiply this to give you positive pi root 2 over 7, and then we subtract 1 off the power, minus 3. Okay, example number 1. We're given this polynomial with some negative indices and positive indices, and we need to differentiate it. So we can just do it term by term. So minus 8x to the minus 3. That's minus 3x squared. And the minus 3 multiplies to 4 gives you minus 12 x to the minus 4. That's a constant term, will become 0, and that's the linear term, will become 3. Okay, example number 2, we're given a function g of x, and we need to differentiate it, and we can see there's these reciprocal functions, so we have to first convert them into negative indice notation. So g of x, that becomes x to the minus 7, plus this becomes 4 x to the minus 2. The next term we just copy, there's nothing to do for that one. And this term we just have to be careful that the 3 doesn't come up with the x, it stays where it is, so that's a 1/3 x to the minus 5. And here we have a 3/4, a negative 3/4, and the x, when it comes up, becomes x to the minus 1. Okay, now we can differentiate it term by term. So g of x becomes minus 7 x to the minus 8. That becomes minus 8 x to the minus 3. This becomes minus 4x. And here the minus 5 comes down and multiplies to 1/3. That's minus 5 over 3 x to the minus 6. And here the minus 1 comes down, multiplies the negative 3/4. So that becomes positive 3/4 x. And when you minus 1 off that, you get minus 2. Okay, example number 3. We're given this function that we need to differentiate. And we can see some brackets. So the first thing we need to do is to expand the brackets. Okay, so 3x to the minus 2 times 2x to the 4. That gives you 6, and here we add the indices, that gives you 2. So that's 6x squared. Here we get 3x, because you have 3 minus 2 is a 1, so that's 3x. Here we have negative 12. The x at the minus 2 and the x squared cancel, so we're just left with a negative 12. Here we have 18x to the minus 1. And here we have minus 9x to the minus 2. Okay, and now we're ready to differentiate. So y dash equals 12x plus 3. The minus 12 becomes 0, and this becomes minus 18 x to the minus 2, and the negative 2 times is the negative 9 to give you plus 18 x to the minus 3. Okay, example number 4, we need to differentiate this fractional polynomial, and we begin first by expanding the numerator. So that's a 4x squared. That's plus 12x minus x. It's plus 11x, and that's minus 3. And that's all over x to the 4. And now we still can't differentiate it yet. We have to now split up the terms. So 4x squared divide x to the 4. I'll do it in 2 steps. I'll just split it up first. So here we've just split up the fraction into this, and now we can simplify each term. So you minus the indices. 2 minus 4 is minus 2, so 4x to the minus 2. This is 11, and that there's a 1 there. I'll put the 1 in. So 1 minus 4 is minus 3. This is 3x to the minus 4. Okay, now that we've got it in this form, we can finally differentiate it. That gives us minus 8x to the minus 3, minus 33x to the minus 4, and then plus 12x to the minus 5. And that's it. So you don't have to do this step. We could have went from here to here usually, but we just did an extra step.